Okay, so in today's video, we're going to be talking about the essential formulas you need to know in order to absolutely demolish the digital SAT, the math section, okay? So the first formulas you'll need to know is going to be about lines, especially the slope, midpoint, distance, standard form of a line, y equals mx plus b, all those equations. So we'll start off slow, and then we'll slowly work our way up, okay? So the first formula you'll need to know is going to be the slope formula, right? The slope formula is basically the change in y, or the rise, the change in y over the change in x, okay? That's pretty much all it is. This is the line you have over here. The change in the y would be, of course, for this line, it will be positive, and the change in x would be also positive. So we have this example over here. Anyway, actually, let me just go ahead and kind of explain this formula. On the top side, we have the change in y, so y2 minus y1 over x2 minus x1. You could also do y1 minus y2, but then you also have to flip the bottom one. You can't do y1 minus y2 over x2 minus x1. It has to be y1 minus y2 over x1 minus x2, okay? So it just has to be in order. Just remember that. So in this example, we're given two data points, and we have to find the slope, right? So we would go ahead and figure out that this is our y2 value, and this will be our y1 value. I just like to count 1, 2, 1, 2, just for convenience. So anyway, we have the y value over here, y2, y1, and we're going to just set them, just substitute values into this equation. So we have 9 minus 1 over, and then we have to do x2 minus x1, right? So this would be our x2 value, and that would be our x1 value. So 3 minus 1. This would give us 8 over 2, which would be 4, okay? So the slope for this, or the m value, you'll likely see as an m value, was going to be 4, okay? Pretty straightforward, pretty basic, nothing really too special about that. Same over here with the midpoint, like just substituting values into the equation. We know how to find x1 and x2, y1, y2. All we have to do, so let me just kind of let you guys visualize this. Let's say we have a line, right? Let's just do it for this specific example. This is the point 5, 5, and this is the point 6, 9, right? The midpoint of these 2 points would be the exact middle point right over there, okay? That'll be the midpoint, meaning a point that is equidistant from this point, point A, and equidistant from point B. That's really all it's doing. And you're just taking the average. You're just taking the average of the x values and the average of the y values. So let's find the midpoint of these 2 points. x1 plus x2, this would be x1. Actually, for this one, it doesn't matter which one is x2. You could have this one x2 and this one also x1. Doesn't really matter, as long as you're adding up the x values. So x2 over here, that will be 5 plus 6 over 2, because you have 2 values, right? It's pretty much the same thing as taking the average or taking the mean of something. You add up your values, and then you divide by the number of values you have, right? So the 5 plus 6 over 2, and then comma, we do y1 over here, and y2. So that would be 9 plus 5 over 2. And then we have to simplify this. So 5 plus 6 over 2, that would be 11 over 2. 11 over 2, comma. 9 plus 5 would be 14 over 2, or 7. That would be your midpoint. So this point right over here, this point would be 11 over 2, comma 7. Okay? It's pretty straightforward, to be honest. The next formula is going to be the distance formula. This is one that you don't really need to know, but I mean it's good to know it, okay? Because you could also have like different other methods just for solving this, kind of like it's pretty much the same thing as the Pythagorean theorem, just written in a different way, okay? So what the distance formula tells us is the distance between 2 points, and sometimes it can be hard to tell that because it's diagonal. You can't really just count like from 1 to 5. Oh, it's 4. Not really how it works. Okay, it's kind of different. Anyway, so we had the distance formula over here to make things simpler for us. x2 minus x1 squared. That will just be the change in x values. Square them to make them all positive. You know, you don't want any negative values. You don't want to have a negative distance. That doesn't really make sense. And then you have y2 minus y1 squared. Again, same reason. Y of it squared. You can take this the square root of all that. So we're gonna go ahead and do an example over here. We're going to try to find the distance between the point A and point B. So point A, point B. Now I've already labeled the x1 and y1 values as well as the x2 and y2 values. Let me just erase this. It's not actually 4. Anyway, so we're going to go ahead and just plug in values into the distance formula and just see what the length of this line is. So x2 would be 5 minus 1 squared, right? x2 minus x1, and then plus y2 minus y2 is 5 minus 1. Wow, incredible. Anyway, we're going to go ahead and simplify this. So 5 minus 1 is 4. 4 squared is 16. So 16, same thing over here, plus 16 is equal to the square root of 32. Okay, that's our distance. You know, you can't really solve. You cannot simplify this. I mean, maybe you can. Shift square root of 32. Well, yeah, you get 4 square root 2. 4 root 2. Okay, so that's your simplified version, or simplified length of this point right over here. Another way you could do it, or this line right over here. Another way you could do it is by doing the change in x. So the change in x would be from 1 to 5, it would be positive 4, right? And then from 1 to 5 in the y direction would also be 4, right? So you could just plug this into the Pythagorean theorem. A squared plus b squared equals c squared. Okay, so a squared would be the change in x, which is 4. 4 squared plus 16 squared equals, oh, not 16, my bad. 4 squared plus 4 squared equals c squared. And you have 16 plus 16, 32 equals c squared. So 32 equals c squared. And then go take the square root of both sides. And c is also equal to the square root of 32, which is the same thing as 4 root 2. So yeah, the same thing you could do with just visualizing it using a right triangle. And you get the same result. That's why you don't really need to memorize it. As long as you can understand it, you're good to go. Okay, so the next important thing that you need to be familiar with is the slope-intercept form of a line, right? This is something that you'll see 100% guaranteed on every single SAT, and you'll have to know what it means, right? So we just talked about slope. We talked about the midpoint of a line. We talked about distance formula. Now we need to know how to represent that in an equation. So for context, we should know what y-intercept is. Y-intercept is the point, like, so let me just draw it over here. The point at which the, when x is pretty much 0. When x is 0 and the value of y. What is the value of y when x is 0? So the point at which the line crosses the y-axis is referred to as the y-intercept. So that's what b represents. And m represents the slope. So the rise over the run, right? The rise over the run. So we have an example over here. And I want to ask you guys to pause the video and identify the slope and the y-intercept of this line. Okay, so the slope would be the coefficient of x, right? You have mx plus b, the coefficient of x would be m, right? So the coefficient of x over here would be 5, so the slope equals 5. Occasionally you'll see the SAT ask you what the value of m would be. The value of m is just simply the slope of the line. And then the y-intercept. The y-intercept would be the constant that has no x term, nothing like that, just the constant. Pretty simply, just 1/2. Okay, that would be the y-intercept. That's kind of why it's called the slope-intercept form. You have the y-intercept over there. You have the y-intercept, and then you have the slope right over there. So yeah, it's pretty simple. This is just something that I want you guys to be familiarized with. You'll see this on the SAT 100%. I would bet $1 million on it. Okay, so the next thing that you will see, and this is kind of what the SAT will try to confuse you by, is going to be the standard form of a line. And it's actually, it looks complicated, but in reality it's really basic. It's just everything is just arranged differently. You can actually derive the slope-intercept form of a line from this equation, and it's very easy. And the SAT will ask you to do that. They 100% will. So there are two main differences. Well, actually everything is different, but anyway, there's actually a very easy way to calculate the slope when you're given the A, B, and C values. But first, let's go ahead and just see what A and B means. Well, what does A and B mean? A and B are just coefficients. A is a coefficient of X, B is a coefficient of Y. You really can't do anything about them. There's nothing. And C also means nothing. You actually have to kind of, rearrange this formula in order to find the actual values of the slope, the y-intercept, etc. So yeah, it's actually pretty useless, okay? So we're going to go ahead and try to find the slope given this equation, right? I'm going to ask you guys to do that. But first, let's go ahead and see how you can find the slope. So over here, we have a few shortcuts that you can take. I'll also show you how to do the long way. But this is a shortcut that you can take in order to find the slope. It's going to just be simply the opposite of B. So if let's say B was 5, you could just go ahead and negative B. Let's say B was 5, negative 5, and A was 4, right? Negative 5 over 4. This would equal the slope. So again, just plugging in values. And the y-intercept would be the value of C right over here, the value of C over the value of B. Just plug in values. Let's say the value of C was 4, the value of B was 2, or no, the value of B was 5, right? 5. So this would also be the y-intercept. Okay, so yeah, just pretty simple finding that thing, but I'm also going to show you guys how to convert from standard form of a line into the slope-intercept form of a line, okay? So I want you guys to pause the video and go ahead and find out the slope of this line in its standard form and also the y-intercept. Okay, so again, we just do the same thing, just plugging in values into the slope and y-intercept formulas I've given you. So the slope would be, this would be your B value, this would be your B value, this would be your A value, would just be, and we have a positive 2B, see if you can see that, plus 2, so it would be minus 2 over, if it was a negative 2y, then it would actually be a negative times a negative, which would be positive. But anyway, for the sake of simplicity, we made it positive. So negative 2 over 5 over the A value, this is our slope. Okay. And the y-intercept would be the value of C right over here over the value of B. So that would be 10 over 2, which is 5, which is our y-intercept. Now, how do we... Whoa, that was terrible. I am sorry. So how would we go from this standard form of the equation into the slope-intercept form? Well, it would be pretty basic. We already found the slope. We already found the y-intercept. So we can just plug those values in. Y equals mx. We can just plug those values into the m value, and we know m is slope, and the b value, which we know is the y-intercept. Don't get confused with this lowercase b and the uppercase b. Students often do that. So like my brother, he always does that. But just try to keep that in mind. So our m value was of course negative 2 over 5. So negative 2 over 5x, and our b value was 5. So plus 5. This is going to be our slope-intercept form. Now we could also do a longer way by actually, dividing, doing all the PEMDAS stuff. And I'll show you guys how to do that just for thoroughness. So we have the equation we have the equation 5x plus 4y equals 10, right? How do we convert it? Well, let's go ahead and start by, because we know in the slope-intercept form, right? Let me just write it again. We know in the slope-intercept form, we have x on the one side, y on the one side, and the y-intercept, or the b value, is on the same side as the mx side, right? So mx plus b equals y, So let's go ahead and try to do that. Well, what can we do to move 5x onto this side? Well, we can subtract 5x, so we get 4y equals now minus 5x plus 10. And then to get y by itself, we would divide everything by 4. Okay, so y equals negative 5 over 4x plus 5 over 2. Interesting. Yeah. So the y-intercept over here is 5 over 2, which I think I might have, yeah. Okay, what? I'm pretty sure it was. Oh, okay, yeah, they're different lines, my bad. Okay, so yeah, the y-intercept over here would be 5 over 2. So yeah, that's pretty much all you have to do. I would honestly stick with, I'd rather stick with this method. This method is much more easier by just, solving for the slope and y-intercept values given the a, b, and c values. In my opinion, that's much easier, but if you don't want to memorize that many formulas, you can always just resort to basic algebra. That'll be it for this lesson. Just a quick recap. We did the slope formula, y2 minus y1 over x2 minus x1. We did the midpoint formula. Make sure you know this. It's really important, especially when you're trying to find the center of a circle given two endpoints, or given the diameter and there's endpoints. You really want to know the midpoint formula in order to find out what the center is, right? Just midpoint formula is just useful for a bunch of other types of scenarios besides just lines, right? You'll see it in circles. You'll see it in, I don't know, maybe even in like finding the midpoint of a rectangle side, whatever. Just it applies to various different things. We have the distance formula. Of course, square root of the square root of x2 minus x1 squared plus y2 minus y1 squared. You could also find out the distance using the Pythagorean theorem. The slope-intercept form of a line, y equals mx plus b, and the standard form of a line, ax plus by equals c, and these formulas that you can use to kind of shortcut your way into finding the slope and y-intercept. So yeah, that's pretty much it for today's lesson. In the next lesson, we're going to go ahead and do a lot of problems with lines, and we'll try to implement our skills. Thank you.